Hello, Algebra 2 students. Mrs. Myers here. We are beginning a new topic, and it is our last topic. It is 2 lessons, although it's going to be spread out into 3 days. This first lesson we're going to take 2 days on, so lessons 15 and 16, and it is a lot more of an algebraic kind of a mini unit, I should say. So hopefully you enjoyed the graphing unit that we did, but we're moving on from that again to our last topic for trigonometry. All right, so we are going to do trigonometric identities, simplifying trigonometric identities here. And in order to see all the different expressions and formulas that we can use for the simplification process, we need to review something that we learned pretty much in the beginning of the module, okay? And that is the unit circle. Oops. Okay, so let's just get a nice little sketch here going on of our unit circle. All right, so remember it is a circle that is centered at the origin and whose radius is 1. So what we know about any circle whose centers at 0, 0 and whose radius is 1, hopefully we know this from what we did with equations of circles in geometry and earlier in the school year, is that has the equation of x squared plus y squared is equal to 1. Okay, now what we know about all points x comma y on the unit circle, okay, so all points x comma y on the unit circle, okay, is that they represent cosine theta comma sine theta. Okay, so we've talked about that a lot. I mean, that was the whole basis for the trig graphs came from, okay? So if we make substitutions for x and y according to what x and y can represent when we're on the unit circle into the equation of the unit circle, we're going to get a very special identity known as a Pythagorean identity. So let's do that. Let's make those substitutions. Okay, so where we have x and where we have y, okay, we're going to make those substitutions. So we've got for ourselves cosine theta quantity squared plus sine theta quantity squared is equal to 1. Notice how I use parentheses to make those substitutions. Now, we don't go around writing cosine theta in parentheses squared and sine theta in parentheses squared. We write cosine squared theta plus sine squared theta. Okay, just so you know, that's typically the way that we write it. So anyway, this right here is one of our 3 Pythagorean identities. Okay, now what is important to realize about our Pythagorean identities, since it's an equation, okay, is that it can be rearranged just like any other equation can be rearranged through the identity properties of addition, subtraction, multiplication, addition, and division. So specifically with addition, subtraction, we're just going to do a little rearranging here. And if I was to subtract sine squared theta to each side, I could get this rearranged to say cosine squared theta equals 1 minus sine squared theta. I also could go back to the very beginning. I could subtract cosine squared theta from each side, and I could rearrange this to say sine squared theta equals 1 minus cosine squared theta. Now, there are other rearrangements that I could make from this, but honestly, these are the 2 most common. So I'm going to write those down right here. Okay, so this is our first of our 3 Pythagorean identities. Now, how we get the other 3, okay, is we are going to use the division property of equality to transform this into what looks like a new equation, okay? So we're going to go back to the beginning here with saying cosine squared theta plus sine squared theta is equal to 1, okay? And we are going to divide both sides through by cosine squared theta. Now that's a division property of equality, so I'm perfectly allowed to do that, okay, perfectly within my mathematical right to do that. So anyway, what happens when we take a binomial and we divide it by a monomial is we get to separate this into 2 fractions. We get to say that we have cosine squared theta over cosine squared theta, and we get to have sine squared theta over cosine squared theta, right? We get to separate that into 2 fractions. Now that's still equal to 1 over cosine squared theta, okay? Now, in order to write what these are equivalent to, well, this one's very easy because anything divided by itself is always 1, okay? We need to recall some things that we have learned throughout this module, okay? And that is our quotient identities and our reciprocal identities. So let's start with the reciprocal identities. Okay. Okay, so we have cosecant theta is equal to 1 over sine theta. Okay, now that also means that sine theta is equal to 1 over cosecant theta. We've got secant theta is equal to 1 over cosine theta, which that also means that cosine theta is equal to 1 over secant theta. And we also have cotan theta, which is equal to 1 over tan theta, and that means that tan theta is equal to 1 over cotan theta. Okay, so those are your reciprocal identities. And then we also have what's called our quotient identities. Okay, there's two of those. And the quotient identity says that tan theta is equal to sine theta over cosine theta. And it says that cotan theta, well, since cotan is the reciprocal tangent, is equal to cosine theta over sine theta, okay? So given these, okay, let's just kind of box them off over here. Okay, so given those identities, we're now going to make substitutions. So you see how it says sine squared theta over cosine squared theta? Okay, well, that's really the same thing as saying sine theta over cosine theta quantity squared. Okay, and you see how it says 1 over cosine squared theta? Well, that's really the same thing as saying 1 over cosine theta quantity squared. So what that allows me to do is come over here and see sine theta over cosine theta. That is another way of saying tan theta. So I get 1 plus tan squared theta. That means tan theta quantity squared, which means tan squared theta. And over here, 1 over cosine theta, 1 over cosine theta is the same as saying secant theta. And secant theta quantity squared would mean secant squared theta. So this is Pythagorean identity number 2. Okay, but just like we can rearrange this one through our adding and subtracting properties of equality, we can do the same here. So if I was to subtract tan squared theta from each side, I could get for myself 1 equals secant squared theta minus tan squared theta, okay, from that. And if I subtract 1 from both sides, I could also rearrange this to say tan squared theta is equal to secant squared theta minus 1. Now, there are other variations of that, but those are the two most common. Now, not done yet, because I said that there were 3 Pythagorean identities, and we've only done 2 so far. So here's one. And here's another. So we got one more to do. So we're going to go back to the beginning again. Okay, we're going to go back to cosine squared theta plus sine squared theta is equal to 1. And instead of dividing both sides by cosine squared theta, we are going to divide both sides by sine squared theta. Oops. Okay, now what we get to do when we're, again, dividing by a fraction, okay, when we're dividing by a monomial into a binomial, is we get to separate this into 2 fractions. So we're going to write cosine squared theta over sine squared theta, and we're going to write sine squared theta over sine squared theta, and we're going to, of course, over here keep 1 over sine squared theta. Now, I'm not going to take the time to do what I did here. Hopefully you can kind of just think about it, is when you've got cosine squared theta over sine squared theta, that's the same thing as saying cosine theta over sine theta quantity squared. Well, since cosine theta over sine theta is cotangent theta, then this is the same thing as saying cotangent squared theta. Here, of course, this is 1. Anything divided by itself is 1, okay? And then here, 1 over sine squared theta. Again, that's kind of what I did up here. I'm not going to write it, but just think about it. It's 1 over sine theta quantity squared. And 1 over sine theta is the same as cosecant theta. So this is really cosecant squared theta, okay? So this is Pythagorean identity number 3. Okay, and just like all the others could be rearranged, this one could be rearranged as well using addition and subtraction properties of equality. So I could subtract the 1 to each side, and I would get cotan squared theta equals cosecant squared theta minus 1. I could subtract the cotan squared theta from both sides, and I would get 1 equals cosecant squared theta minus cotan squared theta. Okay, so I want you to take a good look at all this because this is very, very important. We're going to keep coming back to this. Now, if we were in class, I would tell you that all this had to be memorized, okay, that you would not be able to have it as a reference, but of course, we're in different times here right now, so use it as your reference. So do not lose right now what you just wrote all this on. You can either flip to the back to continue with more notes or go to a new sheet of paper, but I'm just going to flip to the back here, and we're going to do some practice examples on how we use all that information, okay, to simplify trigonometric expressions. All right, so let's go to our first one, okay, the directions. Oh, pardon my camera there. So simplify each expression. Okay, so we know what simplify means, just make it simpler looking, okay? So we're going to start out kind of basic here. Okay, what if I give you sine theta, cosine theta, tan theta as an expression? I say simplify that expression. Now, because you see no operations at all, this is really just multiplication. Now, what we can do to simplify this expression is we can take tan theta and we can make a substitution for it. Now, what we know about tan theta, let's go to the other side here. Okay, well, we've got lots of things to say about tan theta, but what we're going to use here is that it's equal to sine theta over the cosine theta. Now, the reason why I'm going to do that is because, okay, this is where like your algebra skills come into play. Okay, when you are multiplying fractions together, and we could think of these as 3 separate fractions, you are allowed to cross reduce. So now we can divide out that common factor of cosine theta, and we are left with simply sine theta over 1 times another sine theta, which would be over 1. So now this product becomes sine squared theta all over 1, and you don't have to write over 1, and there you go. That is now a simplified form of this expression. All right, let's try another one. What if I gave you cotan theta, secant theta? Okay, so that's along the same lines as this here. Okay, we want to figure out what is the simplified form of this product, a product because there's no operation written, so we know that that's going to be multiplication. So first we're going to go with the quotient identity for cotan theta, which since tan theta is sine over cosine, cotan, right, would be cosine theta over sine theta. And the reciprocal identity for secant theta is 1 over cosine theta. And then in a very similar fashion, like we did before, we can divide out common factors because we're multiplying these 2 fractions together, and we're left with 1 over sine theta. But you never want to leave your expression with a trig function denominator, especially when the numerator is a 1. So we're going to simplify this, and 1 over sine theta is the same as saying cosecant theta, and we're done. All right, let's keep going, keep practicing some more. So what if I give you sine squared theta over tan theta? Now this is division. This is not multiplication, this is division. But what we should know is that we can always turn division into multiplication. Now that's going to be helpful because we're going to take this tan theta and we're going to make a substitution for it according to the quotient identity here and turn that into sine theta over cosine theta. Now, here's our main fraction line, right? So we've got sine squared theta is now being divided by a fraction. That means that we've got sine squared theta, which I can put over 1, is being multiplied by the reciprocal of this, right? If it's being divided by a fraction, it's the same as multiplication by the reciprocal. And now I can cross reduce, okay? What I'm going to cross reduce out is 1 of the sine thetas, right? See how this is sine squared theta? Okay, so it's sine theta quantity squared, which means sine theta times another sine theta. So I'm going to divide out 1 of those sine thetas. And then what I'm left with now is simply the product of sine theta and cosine theta. That doesn't look as simplified as the other problems, but it is still nonetheless more simplified than what I started with. All right, continuing on. How about we try a little bit different idea here. So if we've got 1 minus cosine squared theta over sine theta, although what I showed you from working with Pythagorean identities is that when you have a fraction made up of a binomial numerator and a monomial denominator, that yes, you could separate this into two separate fractions. That would not be really that helpful here. But what would be helpful is looking at that numerator. See how the numerator says 1 minus cosine squared theta? I'm going to flip over here, okay? Well, 1 minus cosine squared theta is one of the rearranged forms of your Pythagorean identity. Now, that allows you to make a substitution for that expression of 1 minus cosine squared theta for sine squared theta, okay? So I'll give you a big major hint right now, okay? Anytime you have a power of 2, a squared, being used in your trig expression, Pythagorean identities are a very likely case of what you're going to use to make a substitution, okay? So 1 minus cosine squared theta is sine squared theta. So we're going to make that substitution. Now that is all over sine theta as your denominator. Well, now this becomes a pretty easy problem because I can just take one of those sine thetas and divide it out, and I'm left with just sine theta, and that's it. Okay? Now, continuing along the lines of your substitutions with Pythagorean identities, okay, what if I flat out give you cosecant theta times in parentheses 1 minus cosine squared theta? Now, you might think, okay, that the best thing to do is distribute and clear those parentheses. And I'm not saying that you wouldn't ever not want to do that. I mean, in fact, there are some problems where the distribution to clear the parentheses is what's going to help you to do some simplification. But right now, we don't want to do that because then we'd be losing a very, very obvious substitution that needs to be made. And that's right here. See this? 1 minus cosine squared theta that we had here? That's what's inside the parentheses. So what we're going to do is take that and we're going to substitute it with sine squared theta. Okay, always look for those expressions that come from your Pythagorean identities. Now, that's being multiplied by cosecant theta. See, but I'm going to take cosecant theta and I'm also going to make substitution for that as 1 over sine theta, because that is your reciprocal identity. And now, see, put that over 1, I can cross reduce out one of the sine thetas, and all I'm left with is just a sine theta. Okay? All right, continuing on in a very similar fashion, okay? What if I give you cosine theta sine squared theta minus cosine theta, okay? So I'm not sure if you can kind of envision that this really is the kind of expression that you would get if you had distributed here, right? Is you'd get this cosecant theta being in two different terms, right? Because it was a factor that was being distributed throughout a binomial expression. Well, how about we take this, therefore, see how there's a cosine theta here and a cosine theta here. Why don't we factor out that cosine theta that's in common, and that will leave us with sine squared theta minus 1, right? Now, that sine squared theta minus 1, that is an expression that we're going to be able to use to make a substitution from our Pythagorean identities. So let's see what that would be, okay? Now, it's not exactly right here. See, this says 1 minus sine squared theta, and be careful, we're looking for sine squared theta minus 1. So come back up here to the original. If I wanted one side to say sine squared theta minus 1, wouldn't I have to take that 1 and subtract it over? Now, with that being said, if I wanted just that expression by itself on the left-hand side, sine squared theta minus 1, I would need to take this cosine squared theta, and I would need to subtract it to get it over to the other side, which would actually give me the substitution of sine squared theta minus 1 being equal to negative cosine squared theta. Okay, so make that substitution. Now I'm going to keep that inside parentheses because if I don't, it's going to look like it's a subtraction between these two terms, and that's not what I want. What I want is cosine theta being multiplied by negative cosine squared theta. Well, what do you think that's going to give you, right? So if it was a plain old x, what would happen with x times another x squared is you would get an x cubed, right? Even if that x squared was negative, okay, you would just get a negative x cubed. Well, that's what's going on here, except we got negative cosine cubed theta. All right? Okay, one last one to go. One more example. Okay, hopefully you're getting the hang of this. So we have now sine squared theta over cosine theta, and we're going to add to that cosine theta. All right, so we have a fraction being added to essentially another fraction, so I can put that over 1. And what do we need in order to add and subtract fractions? We need a common denominator. Okay, so the common denominator here would be cosine theta Now this fraction already has a denominator of cosine theta, so the numerator is going to stay as is, okay? But how about over here? See, I got my denominator as 1, but I need my denominator to be cosine theta. So I'm going to multiply by cosine theta over cosine theta, right? Can I multiply by a form of the number 1, so I'm not changing the expression's identity, okay? But I am going to change what it looks like so that I can have a common denominator. So now the numerator is going to become cosine squared theta, right? Because cosine theta times another cosine theta, so cosine squared theta. Now from there, I can join these two together and write them as one single fraction with that common denominator of cosine theta, and the numerator is going to be the sum of sine squared theta and cosine squared theta, right? Well, that is actually a substitution that can be made from a Pythagorean identity. Okay, so come up over here. Okay, again, anytime those quantities are squared, go to your Pythagorean identities. Very, very often you're going to be able to make a substitution from there. And look, see, cosine squared theta plus sine squared theta, that's equal to 1. So I'm going to come here, and I'm just going to make that substitution with a 1. Now the thing is, though, once I do that, I don't want to stop, because 1 over cosine theta, that is a reciprocal identity, that is secant theta. Okay, and now I'm all set. All right, so that was day 1, which is actually going to be very, very, very closely related to what we do in the lesson 16, okay? But lesson 15, day 2, which will be the next lesson, is going to be still using these Pythagorean identities, but not in the same sense of simplifying an expression, okay? So you'll see when the next video comes out for the next day, but hopefully you kind of felt like you got the hang of this, and good luck with the assignment. Hope everyone is well.